In this video, we'll be looking at Chapter 22, Section 4, which deals with organic reactions. Now, the first of these reactions that we're going to be examining are what are known as substitution reactions. And this is basically where one atom or group of atoms replaces another atom or group of atoms in an organic molecule. So, for example, in this reaction between methane and chlorine to yield chloromethane, CH3Cl, and hydrochloric acid, you can see that you start off with a hydrogen in the methane atom and a chlorine in the chlorine atom, and basically through the use or through just pure electronegativity, really, the two atoms will sort of swap places in this reaction, and you can repeat this process again and again to yield the CFCs, the alkyl halides we talked about in the last video, as well as tetrachloromethane, some chloroform, etc. So the next reaction we're going to be looking at are what are known as addition reactions. And addition reactions are basically where you take an atom or a group of atoms and add them to an unsaturated molecule, thus increasing the saturation. So for example, if we start off with, this section of an oil of some sort, let's say it's vegetable oil, you can run hydrogen through it through a process known as hydrogenation. And through this process of hydrogenation, you can break up the double and triple bonds that may be collecting in this organic compound chain. So for example, if you have this part of a fatty acid chain with a double bond in it, you run hydrogen through it in the form of H2, and you can break this double bond and make up for it by attaching these hydrogens. And now you can see that there's no double or triple bonds in this section of the molecule, so therefore this section is saturated, whereas before it was unsaturated. And this is actually a process through which they convert a lot of oil into saturated fats and so on. Now the third reaction we're going to be looking at is what is known as a condensation reaction. And this is basically a reaction in which two molecules or two parts of molecules combine, usually by creating some smaller molecule. So for example, if we look at these two amino acids right here, you'll notice that one has a carboxyl group over here, and the other has an amine group attached. And what you'll find is that you can basically, by reacting the hydroxyl group at the end of the carboxyl section of the molecule, as well as this hydrogen, you can form water, but that will leave these two bonds open. These two will naturally then want to combine, making these two amino acids into a dipeptide molecule. And this is a process that happens over and over again within your body to form proteins. And this whole process is facilitated by organelles within your cells. Now the last of these four reactions is what is known as an elimination reaction. And basically what happens in an elimination reaction is you have a simple molecule, such as water, forming from adjacent parts on a larger organic compound. So for example, if you have ethanol and you speed up this process with sulfuric acid, what you'll find is that you can decompose it into ethene, which has a double bond here, as well as water. And that's just basically because this hydrogen and hydroxide eventually react together to form, H2O. And it's called an elimination reaction because you have parts up here to begin with, and you don't afterwards. Basically, you eliminate these two groups from the compound. Moving on now, we're going to be discussing polymers, which are basically just large molecules made up of small units joined by organic reactions. So polymers are all organic compounds. And these small units have a special name. They're called monomers. So mono meaning one, and poly meaning many. You combine many single monomers to form a polymer. And as a last sort of vocabulary note, a copolymer is basically just a polymer formed from different types of monomers. Alright, so looking at polymers now, we're going to specify certain types of polymers, beginning with addition polymers, which are basically just polymers that are formed by addition reactions between monomers. So for example, if you start off with n number of ethene molecules with this troublesome double bond in the middle, and add them, basically put them through a process using a catalyst, you can break down the double bond into a single bond and then chain them together. So you can have CH2s here, here, which will then continue to attach. And basically, you can form these long chains out and out and out, proportional to how much you started with. So if you have n number of ethane molecules to start with, you can then form n pieces of what is known as polyethylene. And there are many types of polyethylene. For example, it's used in plastic bags, like milk jugs, all sorts of plastic materials use this polyethylene because the long chains it forms, which can then overlap, are really strong because it's hard to push them past one another. So you can't really get this chain down below this chain, and which means that a force trying to compress this will meet significant resistance. And the last type of polymer we're going to be looking at in this video are what are known as condensation polymers. And as you may guess, these are polymers that form via condensation reaction. So for example, if you have an amine group on one end of a molecule and a carboxyl group on the other, as we've already seen, you can have a condensation reaction which forms water molecules and combines these two, basically using that former bond that belonged to the hydrogen and hydroxyl respectively. And how many of these bonds you form is proportional to how many of each molecule you start with. Now, condensation polymers are usually formed, they're usually copolymers, so they have two types of two or more types of monomers. And this is useful because, for example, if these are actually the same molecule, you get rid of that prime, and you have an amine group on one end and a carboxyl group on the other. This can then have another amine group down here connecting to another carboxyl group, etc. And you can form long chains by condensing out this water. And this is how you form things like polyester and polyamides. Now, for example, nylon is a polyester, as well as many fabrics used in clothing are polyesters, and they're formed from reaction of dialcohols with carboxylic acids. They're used in, tires, food packaging, fabrics, etc.